Hello world and welcome. Today we are going to see what are artificial neural nets, or ANN for short, in classification. My name is Harris and let's get started. For more tutorials, hit the subscribe button or leave a like comment there. So what are the pros of deep learning in general? It's basically to reduce the need of feature selection and feature engineering, which is the most time-consuming part. By not selecting any feature, this is a pretty easy job. It will cause a really high accuracy, and you can apply it on really complex problems and also adapt it on new problems as well in the future. The cons are you need a lot of amount of data, and it's extremely computationally expensive to train. So many times you need, let's say, GPU to let's have a really good model. So you also need to have a really strong theoretical foundation to understand sometimes what is the output of a neural net. That's why it's sometimes like a black box. If you consider it here, you see a neural net with input and output, and between we have two hidden layers that connected to each other, all the neurons, and this is how it looks like. Today we are going to predict if a patient has breast cancer or not. Therefore we have just here some example pictures of, let's say, on the left side we have a positive outcome or target that somebody has breast cancer or not. So yeah, let's check the code. So first of all, we are going to import all the packages. Afterwards, we are going to load the data. Therefore, we use the load breast cancer to just have all the data from sklearn. And we're going to preview the data where you see here 30 columns or 30 features, which is pretty good for this example. We are doing a feature scoring to just see what are the most important features, like worst area, mean area, or error. This is pretty good to have the best features who are really bringing you benefit. Afterwards, you can also hist the outcome or the target to see if your data set is balanced or unbalanced. Then you can split everything within train and test data and start to build your model. Therefore, we use keras, and we are using a sequential approach of our neural nets, and the first dense layer here has 64 inputs or neurons. We have 30 input shapes because we have 30 columns, and we are using sigma function because it's a classification in this case. Then we have an output layer, only one, because the outcome is only between 0 and 1. We're using the Adam optimizer, and we are training the model within 100 epochs, and then after applying everything, we are hitting the summary button, and we see what the summary looks like. We have 64 neurons per layer and one outcome layer, and more than 2000 parameters, and we are going to evaluate the model. And there we see on the test data 93% accuracy, which is pretty good. Of course, you can also set up the learning rate down or put more layers, of course, or making it more accurate. The weights here are in the range of 0.8 and minus 0.8, and the bias is 0.14, and the minimum is minus 0.5. There you can also see the bias, like the offset as well, and the weights itself. And after plotting the accuracy, you can see we're using 100 epochs, but you can see that after 10 or 20 epochs, you can already have a really good accuracy this time. And so you have here the POX and the accuracy on the y-axis. So thanks for watching. For more content, hit the subscribe button or leave a like, comment there. Thanks a lot and see you soon.